Hi, here on the workbench today is another thermal camera for me to review. This one is Kaiweets KTI-W02, and it was provided to me by Kaiweets. As usual, I will leave a product link in the video description below for those who are interested in getting one after watching this video. On this channel, I have reviewed quite a few thermal cameras by now, and the KTI-W02 is another standalone unit that sports a 256 by 192 IR sensor, which is typically of the UFPA type. At the moment, 256 by 192 is the sweet spot for these thermal imagers. Higher resolution ones do exist, but they're a lot more expensive. And the majority of the thermal imaging cameras I've reviewed on the channel have this resolution. But they are not all created equal. It pretty much all depends on what quality the IR imaging sensor is used. Size-wise, the KTI-W02 is relatively compact. Just to put things into perspective, here is the Viver SC240N that I have reviewed a while ago, and you can see that these thermal cameras put side by side, you can see the KTI-W02 is a little bit smaller than the Viver. And also, even compared to the KTI-W01 we reviewed a while ago on the channel, you can see that how much smaller the KTI-W02 is. But these two thermal cameras currently are selling for roughly the same price. So obviously there are some pros and cons of each. We will try to take a look a little bit later. Also, as you can see, the KTI-W02 also has a visible spectrum camera built in. It's right here. On the front, you also get a laser pointer and a flashlight used in conjunction with the visible spectrum camera here. Inside the product box, you get a semi-rigid product carrying case, which is very nice. And you can see inside you can put a camera in. You also get this charger by the look of it, and that definitely will come in handy. Of course, you do get a USB cable in the product manual as well. Here is the charger. You can see it is rated for 5 volts and 2 amps. Nothing special, but it does come with this interchangeable plugs. Of course, the one supplied is for North America. I think that's a very nice design here. Let's plug it in. You can see that this is how it comes in place. Let's actually take a look at some of the specifications briefly, as they are quite comprehensive. So let me bring in the spec sheet. You can see this is for the KTI-W02. Let's zoom it in a little bit. And first thing you see is the detector type. You can see the detector used is Vox. Now, as I mentioned earlier, these type of devices usually use uncooled focal planar array sensor, and Vox is really the semiconductor material used, which is vanadium oxide. And let's see what else. You can see that the minimum object distance is specified at 30 centimeters. It is not super close, but you can get to a reasonable distance and observe some smaller objects. We'll take a look at this shortly, obviously. Here, NETD, or the noise equivalent temperature difference, is another important parameter, and you can see that the specification is at less than 45 millikelvin. This is definitely on the lower side of all the thermal cameras I have reviewed on this channel. Typically, this number is between 45 millikelvin and 65 millikelvin. The smaller the number is, the less noisy the obtained thermal image. The refresh rate is specified at 25 Hz, which is pretty decent. You notice that it says the focusing mode is focus free, which it just means it's fixed focus. The measurement range is actually pretty wide, from -20 degrees to 550 degrees Celsius in 2 ranges. Since it supports auto switching, I'd assume the switching speed is pretty fast. Unlike the Unity UTI 690B I reviewed a while ago, which takes roughly half a minute to switch between the 2 different modes. We will definitely have to take a look at this later on. What else? You can see that we also have a digital camera here. This is the visible spectrum camera. And although it is only a 2 megapixel camera, actually this is all that you need for capturing high resolution pictures. This one, I believe, can capture up to 1600 by 1200, which is more than sufficient. Now, it might disappoint you if you want to use this camera to record videos, as it mentioned here that the shooting mode is for photo only. That said, you can connect this device to a computer as a camera device and can use the computer to capture the video if needed. The quoted battery life is definitely quite impressive. You can see here, battery working time is greater than 16 hours. Let's see what else. This camera is IP54 rated, as you can see it's mentioned in the spec here. This just means you can use it in outdoor environments and it can withstand some accidental splash, but definitely doesn't mean that it's waterproof. Of course, like a lot of the handheld cameras I have reviewed, this one also comes with this tripod mount. You can put it on a tripod when taking your thermal images. Alright, I've been talking for a while. Let's actually power it on and take a closer look. Oh, by the way, the protective film is still on. Let me first remove that. And let's power it on. And wow, it's on already. It literally was almost instant on. This is the fastest boot up time I have seen among all the thermal cameras I have reviewed so far. Quite impressive. Now, I looked at the marketing material and the fast boot time feature was only mentioned on the product box. Let me show you here. So this is the product box. You can see that the only thing indicating this fast boot time is this 1 second boot here. But if you look at the other prominent areas, we don't see that mentioned anywhere else. If I were in charge of their marketing department, I would definitely put this feature on a more prominent place in all of their marketing materials. Let's just try that again. So I press this button and I'm turning it off. You can see the power off is almost instantaneous as well. Let's power it on again. Yep, it took just literally around 1 second. So in my opinion, this fast boot feature alone makes this camera stand out and makes people more likely to use it. Anyway, before we look at the menu items, let's actually take a look at some of the basic operations and get a sense of the thermal image quality here. Now I just powered on the W01 and W02 and you can see them side by side. Of course, the W01 has a much bigger LCD screen here. Anyway, if I move my hand in the background here, you can see the thermal image captured on both of the cameras. Now, subjectively, the W02 image is a little bit sharper in my opinion. Of course, you can't really see it here, but later on we will do some more comparison here. Now, if I look at the background here, let me just tilt the camera here. Of course, all the equipment currently is powered off, but you can still see the equipment in the background from the thermal camera here. Now, it's a little bit hard to see here, but it does look like the W02 can capture a little bit more detail. Now, this excellent image quality I think is due to its low NETD figure. Also because on this channel we're more interested in electronics, let's actually take a look whether or not this camera is suitable for electronics work. And here I have this Arduino board powered on for a while now. Let's take a look using the W02 first. And you can definitely see, for example, at this distance, you can see all the components heated up on that board. And it definitely looks very crisp from this distance here. Now compare that to the W01, you can see that we can see here, let me just turn it around. You can still see all the components, but I would say that the image was definitely more crisp on the W02. So let's do a quick comparison here. This is W01, and let's take another peek with the W02 here. And you can see that the picture is definitely very crisp. Of course, if you're doing any close-up inspections, you will need a macro lens, but this unit does not currently offer a macro lens just yet. Alright, with that Arduino board in the background, let's take a look at some of the user interfaces here. So with the up and down button, you can actually change the operation mode here. For instance, this is IR only, which is a thermal camera, and here is the picture-in-picture. And you can see that it can be useful because you have an IR image in the middle. Of course, this is blended with the background image. Now, these two images are not currently aligned because the distance is too close. But you do have the ability to see the IR image and the visual spectral image at the same time. So let's see what's next. This is the visible light image only, and you can just use it as a standard camera here. Alright, what's next? This one is MIF. Now, I had to refer to the manual to figure out what MIF stands for. Basically, it is the multispectral image function mode. It actually is just a combined visual spectral image with edge sharpening along with the IR image. Let me zoom in a bit so you can see the MIF mode a little better here. You can clearly see we have the visual image, of course right now it's misaligned, and that is enhanced as we have the edges shown here. Now, with a 256 by 192 thermal image resolution, I don't think the fusion mode is that useful anymore, as you can clearly identify the object even without, for example, the visual camera turned on. So if you're just doing IR only, you can still see pretty much everything you wanted to see. So in my opinion, the fusion mode just adds a lot of confusion, especially these are not aligned. Of course, at a further distance, the image will be aligned, and I suppose you can get a better sense of what you're looking at. And as I just mentioned, at this distance, the image alignment is quite a bit off. Now, this is actually one of the problems I have found in almost all the thermal cameras I have reviewed. Now, this is not inherent to the thermal camera's problem because you can see it here. The visual spectral camera is here, the IR camera is here, so there is some offset. Of course, it cannot be aligned at all distances, you have to manually adjust. But this is definitely an issue if you want to combine the visual spectral image and IR image. Anyway, it's good that you have these options. But for me, I would probably just stick with the standard IR image. Oh, by the way, when you take a picture, it will actually capture both the IR and visible spectral images, and you can view them both later on. And better yet, using the software provided, you can actually flip between the IR and the visible spectral image. I assume the visible spectral image is stored in the same file as the IR image, as otherwise you wouldn't be able to do that in software. If you take a look at the captured images, you will see that the visible spectral camera images are also stored separately, so you can always view them independently if you're not using the supplied software. Alright, now let's take a look at some of the menu options. To get to the menu, you press the OK button, and let me zoom in. Obviously, the gallery is where the images are stored, so you can see here we can review, and that's the image we just took. Go back. And the temperature range right now you can see is set to auto. Remember we mentioned earlier, this camera has two temperature ranges. So let's go take a look here. So the first range is -4 to 302 Fahrenheit. And let's actually select that. And if you remember on the Unity camera 260 I reviewed before, that one took about 30 seconds to change between ranges. So let's take a look at how fast we can change the ranges on this camera. So let's hit OK here, and let's go back. So that's probably the default right now. Let's go back and change it to the higher temperature range. So let's go back. And it took roughly a second, you can see. We froze for a second, but now it is displaying. So I think it only took about a second to change it back. So let's go back to -4 to 302 again. Yeah, you can see that. So you can see that changing between these two modes is really fast. So let's change it to auto again. All right, let's move on. The next one is emissivity. We can adjust the emissivity of the material, so that will give you a more accurate reading of the measured temperature here. Next is palette. We definitely have quite a few to select from. So this is black and white. Let's take a look at this one. I don't quite like that one. Let's see. And you get the idea. We definitely have quite a few to select from. My personal favorite, I think, is still the default one. Yeah, these are just too busy. So this is still my personal favorite one. Anyway, you can either turn on the center point or not. And we have the temperature unit. Let's actually change it to Celsius. Here, this is the ROI measure. ROI stands for region of interest. So you can see here, right now, we are essentially measuring the central dot. Let's go back. You can see we have a cross in the middle. That's measuring the center temperature here, and it's shown at the upper left corner here. So let's go back. And we can change this to, for example, a smaller region. And let's go back and see. And you can see now we have a rectangular box here in the middle. Of course, if we come back here and change it to a larger region, you can see that the UI updates accordingly here. So let's see what else we got. Oh, we can even make it bigger. And this is essentially the full screen. Very nice. And let's see what else. We can set temperature alarms. The REF measurement. Now, I wanted to explain a little bit. This is to set the reflected temperature. The reflected temperature is the thermal radiation reflected off the target being measured. We know that the emissivity of the material affects the measurement accuracy, and that's why you need to set the emissivity close to what is being measured, especially based on the material. But the reflected temperature also impacts the measurement accuracy as well. Now, typically, this would be set to the ambient temperature. But if you have a hot object on the site, for example, adjacent to the object being measured, you will want to adjust this value accordingly. This is where we set the default distance, and I'm sure we will have to play with this number if we want to measure the temperature more accurately when doing close-up measurements. Distance unit, auto shut off. We can change it to 5 minutes, 10 minutes, so on and so forth. And given that this battery can last 16 hours, I think I'm just going to leave it off. Screen brightness. Let's see, this is already very bright. Okay, you can make it even brighter. This low brightness, I think the medium is actually the sweet spot here. So laser and floodlight. Now, the floodlight is useful when taking visible spectral images. I'm not sure how useful the laser is, given that the laser is some distance away from the thermal imaging camera here. You can see that there will be some misalignment, so you can't really rely on the laser pointer for alignment. Also, the laser is only triggered when you hold down the trigger button for taking pictures, so you can't really use it as a guide before taking the picture. So let me actually show you this. So let's turn on the laser and floodlight. Now let's actually give it a try. So I press down the button. Oh, you can see actually, no, the image is not taken yet, so I take it back. So actually you can use this to somewhat guide where you are looking at, but of course you can also see that through the screen anyway. I suppose it can be useful in some situations. So for example, right now, if I release the trigger, it will ask me whether or not I want to save the image. So that's a function of that laser and floodlight. So let me come back here. Go back to the menu. I'm probably going to turn off the laser because it's just a little bit annoying. And we'll leave the floodlight on. I'm going to set daytime, language, reset, format. This controls the blending of the picture in picture. Visual. Okay, this is actually the size of the visible picture here. So you can change from 240 by 320 to, here is a 1200 by 1600. So this is actually the size the imaging sensor supports. And USB mode, you can see we have two USB modes here. You can select between the USB mode and also projection. The mode here is actually very useful. When in USB mode, if connected to a computer, it will show up as a flash drive as usual. But if you change it to projection mode, it will send the captured image live stream onto your computer. In this case, you can see the text in the video is somehow mirrored, and also the whole image is upside down. Now, I'm not sure if there's a way to correct that, but it doesn't appear to be an option using the default camera software on Windows. And that's the USB mode. Let's see what else. Camera info. Here we have the firmware and the version info. And by the way, you can see that the supplied SD card is a 32 gig one. I forgot to mention that earlier. And that's pretty much all the menu options here. Now let's take a look at a few more items with this thermal camera. So here is a switching power supply that I used to test other thermal cameras, and I'm going to test with this one as well. So let's take a look. By the way, I will take some still pictures and we'll put on the video here so you can see better, because right now I'm not sure how well it shows up. But you can see this actually gives you a lot of details. You can see the board here. I'm going to tilt that power supply. You can see the inside. Here are some resistors. And we also have a bank of resistors up there. You can see those are captured very well. So the image quality definitely is excellent here. And in my opinion, this is definitely a very good camera for you to troubleshoot circuit board. Even though it doesn't have a macro lens, but you can see we do have a lot of the details on the thermal image to help you identify which component is the culprit here. As I mentioned earlier, you can download the software tool called Thermotools from Kaiweets website. By the look of it, the tool is not specifically designed for this device as it's a standalone tool. And also you can see that it has a lot of capabilities. So I assume this tool actually supports a broad spectrum of devices. So I assume as long as the file format is correct, this tool would be able to support the captured images. And it does allow you to do some basic measurement, as you can see here, and also adjust the temperature range threshold. So clearly the images taken have these temperature parameters already captured in the file. Also, as I mentioned a short while ago, the KTI-W02 is actually priced the same as the KTI-W01 model. So whichever you choose actually depends on your application and your personal preference. In my opinion, both are pretty good thermal cameras, and each has its pros and cons. But if you want one that is more geared towards electronics, I'd pick the W02. As you can see, the close-up images are much sharper. If you need one that can record videos without having to connect to a computer, you will probably want to stick with the KTI-W01. Personally, I would get the W02 for its fast boot-up time. Anyway, I will leave a link in the video description below if you want to check out the other review video. Anyway, I hope you enjoyed the video. If you liked the video, please remember to give it a big thumbs up and don't forget to subscribe to the channel for more videos like this in the future. Your participation makes videos like this possible. Thanks for watching, and I will see you next time.